Mi son sabrosón, hasta se baila en el chaquetón. Mi son sabrosón, hasta se baila en el chaquetón. Ahora vamos gozando, ahora vamos disfrutando, para que baile mi son sabrosón, para que baile el ti, para que baile el reggaetón. Ubiquen en el Facebook, súbelo YouTube, mira te lo digo, mira Marilu, pero que baile conmigo, mira cómo baila. Mi son sabrosón, hasta se baila en el chaquetón. Mi son sabrosón, hasta se baila en el chaquetón. Ahora tú quieres vacilar, te digo con los hacheros, ahora ven para que prueba mi son. Esto te lo digo ahora, te lo traigo directamente del corazón, para que baile, para que goce. Mi son sabrosón, hasta se baila en el chaquetón. Suavecito, suavecito, suavecito es como me gusta más. Mi son sabrosón, hasta se baila en el chaquetón. Para que baile, para que goce, para que baile, para que goce. Mi son sabrosón, hasta se baila en el chaquetón. Son sabrosos para que goce. Mi son sabrosón, hasta se baila en el chaquetón. Ay, pam, 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 pam. Eri Venegas. Thank you, thank you, thank you, thank you, thank you.
En el 3. So, I don't know if you guys know this, but you guys have a Clark Kent roaming the halls around here. A Congero Clark Kent. So, it's our pleasure to introduce Felix and Conga to the next one. It's a new Congero player.
It's the new edition. This is our new song called Bambulaye on our second album, so hope you enjoy it.
I just replaced my entire tech stack with Postgres. Modern software engineering has basically become a subscription management simulator. We've been gaslit by cloud vendors into believing that to build even a basic application, we need to stitch together a fragile distributed web of highly specialized microservices. You wire up a Redis instance for caching, a Kafka cluster for background jobs, Elasticsearch just to power a simple search bar, and a dedicated vector database for that one AI feature you tacked on. By the time you finally deploy your app to your highly demanding user base of yourself and your mom, you're paying a dozen different Y Combinator-backed SaaS startups just to keep the lights on. It is an over-engineered, wildly overpriced trap. But what if I told you that you could take almost all of those shiny cloud dependencies, toss them directly into the incinerator, and replace them with a single piece of boring 30-year-old open source software? The dirty little secret the tech industry doesn't want you to know is that one battle-tested tool can cannibalize your entire architecture. Today, we're stripping your stack down to one unstoppable source of truth: PostgreSQL. Here's how you use Postgres to replace literally everything. Before we start violently dismantling your current architecture, let's look at the weapon that we're using. At its core, PostgreSQL is an open source object relational database system that has been in active development for over 3 decades. Out of the box, it gives you rock solid ACID compliance, meaning when your cheap cloud server inevitably crashes, your user data isn't corrupted. But the real reason it can cannibalize your entire stack is its extensibility. It doesn't just store standard rows and columns. It supports advanced custom data types, multi-dimensional arrays, geometric shapes, and key value stores. This architectural flexibility has led to a massive ecosystem of third-party extensions. It's basically the Skyrim of databases, a rock-solid foundation that you can aggressively mod until it does exactly what you want. Here is how you use it to replace everything. One of the great debates among web developers is SQL versus NoSQL, and the core selling point of NoSQL is handling unstructured data. You no longer need a separate database like MongoDB just to do this. Postgres offers deeply integrated native support for JSON through its JSON-B data type, which fundamentally changes how data is processed. The B stands for binary. Unlike standard text storage that must be parsed every time a query is run, JSON-B converts your JSON payload into a decomposed binary format at the moment of insertion. The true magic unlocks when you apply a GIN, or generalized inverted index, to this column. An inverted index works exactly like the index at the back of a textbook. Instead of scanning every database row looking for a specific key, the index maps the keys directly to the row IDs where they exist. This allows you to query deeply nested JSON properties instantly and join those documents with traditional relational tables in a single ACID-compliant transaction. You get the exact schema flexibility of NoSQL without sacrificing data integrity. Provisioning RabbitMQ or Redis purely for reliable task distribution introduces massive architectural overhead, but building a queue in a standard SQL database usually leads to deadlocks. Postgres solved this elegantly with its native concurrency control, specifically the for update skip locked clause. When building a background worker system, the traditional problem is that 2 workers might try to grab the same pending job row at the exact same time. One locks it, and the other gets stuck waiting. Adding skip locked changes the physics of the query. It instructs the database engine, grab the first available row, lock it so no one else can touch it, but if you hit a row that is already locked by another worker, don't wait. Just skip it and grab the next one. This turns a standard relational table into a highly concurrent, wait-free message queue capable of processing thousands of jobs per second. While specialized tools like Elasticsearch are mandatory for globally distributed log analysis, using them just to power a search bar in your app is massive overkill. Postgres is fully equipped to power advanced full-text search directly by stripping language down to its mechanical roots using tsvector and tsquery. When you insert text into a tsvector column, Postgres parses it, removes useless stop words, and applies linguistic stemming, so a word like running simply becomes run. Furthermore, you can apply the PG_trigram extension for fuzzy matching, the ability to find accurate results even when a user makes a typo. It does this using trigrams, which simply breaks words down into 3-lettered chunks. If a user misspells PostgreSQL as Postgres with 2 S's, the database doesn't look for an exact match. It finds the overlapping 3-letter patterns and returns the correct result anyway, giving you a highly performant, typo-tolerant search engine without syncing data to a secondary cluster. If you're building an AI app, you might consider paying for a vector database like Pinecone. But keeping vector data separate from your relational data creates an architectural nightmare known as the hybrid search problem. If you need to find documents semantically similar to a user prompt, but only if they were authored by a specific user last week, querying two different databases and cross-referencing the results over a network is incredibly slow. You can handle this entirely within Postgres using the PG vector extension. It allows you to store high-dimensional arrays right next to your core application data and supports HNSW, or Hierarchical Navigable Small World Indexes. HNSW is a graph-based algorithm for approximate nearest neighbor search that organizes vectors into a multi-layered structure, acting as a high-dimensional skip list. It allows for fast, scalable vector searches by starting at a top layer with few long-range connections and moving to lower, denser layers to refine the search. This minimizes the number of distance calculations needed, allowing the database to rapidly navigate through neighborhoods of similar data points to find approximate nearest neighbors in milliseconds. Ultimately, you can execute this complex vector math natively while simultaneously applying strict relational filters. We've been talking a lot about how powerful Postgres is, but let's be honest. Provisioning, scaling, and managing testing environments for it can still be a massive headache, and that's exactly where today's sponsor, Neon, comes in. Neon is a fully managed serverless Postgres platform built specifically for the cloud. They've fundamentally re-engineered Postgres by separating compute from storage, which unlocks features you just can't get with a traditional setup. My absolute favorite part about Neon is database branching. Just like you branch your code in Git, Neon lets you instantly branch your Postgres database. Want to test a risky schema migration or a complex query? Just click a button, spin up a copy of your database in seconds with all of its data, and run your tests. If you mess up, your prod database remains completely untouched. It completely changes how you handle dev and staging environments. Plus, because Neon is true serverless, it automatically scales compute based on your application's workload and scales down to 0 when it's not in use. You don't have to over-provision servers, meaning you only pay for exactly what you use. Whether you're building a weekend side project or a high-traffic application, Neon makes Postgres feel modern, fast, and frictionless. Click the link in the description to sign up and deploy your first serverless Postgres database on Neon for free in just seconds. A huge thanks to Neon for sponsoring this video. Now back to even more Postgres. If you're building applications that rely heavily on maps or routing, Postgres isn't just an alternative, it is the undisputed industry gold standard. The PostGIS extension transforms Postgres into a spatial powerhouse using the GIST, or Generalized Search Tree Index. If you ask the database to find all coffee shops within a complex geographic polygon, doing raw mathematical distance calculations on every coordinate would crash the server. Instead, a generalized search tree draws simple overlapping bounding boxes around your geographic shapes. The database first checks these simple boxes, instantly discarding millions of data points that aren't even close, and only performs the heavy, precise geometric math on the handful of points that remain. This routinely outperforms standalone GIS systems. On the other hand, when handling massive volumes of telemetry or event logs, developers reach for time series databases. Postgres handles this natively through declarative partitioning and the highly underutilized BRIN, or block range index. Instead of storing billions of logs in one massive table, partitioning transparently splits your data into physical daily or monthly chunks. As long as your logs are inserted sequentially, the BRIN index is a superpower. Instead of indexing every single row like a massive bloated B tree, it only stores the minimum and maximum timestamps for physical blocks of data on the disk. When you query for a specific time range, Postgres reads the BRIN index, instantly skips millions of physical disk pages that don't contain your target timestamps, and scans only the tiny fraction that do. How about for complex dashboards? The knee-jerk reaction is to pipe data into expensive data warehouses like Snowflake. You can bypass this by leveraging Postgres materialized views. A standard view runs its underlying query from scratch every time a user hits the dashboard, crashing your database under load. A materialized view runs the heavy aggregation just once and physically saves that calculated result to the disk. To prevent stale data, Postgres uses the refresh materialized view concurrently command. Provided your view has a unique index, it calculates the fresh analytics entirely in the background, compares the differences, and seamlessly hot swaps the updated rows into place without ever locking out your end users. For years, we've blindly accepted that you need to write and maintain thousands of lines of boilerplate Node.js or Python code just to shuttle JSON between your database and your front end. You can incinerate this entire middleware layer using tools like PostgREST or the PG_GraphQL extension. Instead of manually writing a new controller and endpoint every time you add a database table, these tools analyze your schema and automatically generate a fully documented, highly performant REST or GraphQL API on the fly. And before you panic about security, Postgres handles that natively too. By leveraging row-level security, you can write strict cryptographic policies directly in the database that guarantee a user can only ever read or write their own specific rows based on their authentication token. Your database securely becomes your entire backend, eliminating the need for a fleet of API servers. While the just use Postgres philosophy is incredibly powerful, you shouldn't entirely abandon your critical thinking. It isn't a silver bullet. Postgres scales vertically with exceptional grace, but horizontally sharding a monolithic database to handle extreme scale introduces immense complexity. If your application actually needs to ingest millions of telemetry events per second, or requires sub-millisecond in-memory caching for millions of concurrent WebSockets, you absolutely must adopt specialized distributed tools. However, until you cross that threshold of massive enterprise scale, leaning on the core battle-tested mechanics of Postgres to run your entire stack is arguably the smartest and most cost-effective engineering decision you can make. Seriously. To really level up as a software engineer, you have to build hard things. That's why I highly recommend CodeCrafters. Instead of building basic apps, they guide you through building real developer tooling from scratch. You'll write your own working versions of Redis, Git, Kafka, Docker, and even modern AI tools like Claude Code. It completely changes how you understand software. Check the description for a link that automatically applies a 40% discount to your account. Also in the description is a link to my free newsletter where I share exclusive deep dives on system design and real-world backend development, the stuff you won't find in basic coding tutorials.
Hey everyone, it's Kevin. Welcome back to the channel. In this video, I'll walk through creating this cozy jungle hut in Blender 3D. This project combines both 2D and 3D elements with the 2D components created using Grease Pencil. This was inspired by a piece I made a little over 2 years ago, and it utilizes a similar workflow. If you'd like more of a deep dive on that, I'll leave a link to the video below. Now, if you're unfamiliar with Grease Pencil, it's an object in Blender that allows you to draw and animate directly in the 3D viewport. This feature makes Blender incredibly versatile for hybrid workflows and is one I really enjoy working with. To create this, we'll start with modeling the treehouse. Then we'll move on to shading and finally finish it off with Grease Pencil elements. It's important to note that, like my other tutorials, this one isn't done in real time. Therefore, if you're trying to simultaneously do it, it may seem fast-paced. I encourage you to take your time with it and pause when needed. I also recommend having some experience in Blender, but if you're new to it or 3D in general, no worries, as you'll still be able to follow along. Lastly, it might be helpful to have a tablet, especially for the Grease Pencil part, but you can get by with a mouse. I'll have this project file available for download on my Gumroad, and I'll have a link in the description. Let's begin. Here, I'm in a new Blender file using Blender 4.2 and in the layout workspace. As we'll be starting with modeling, I've set the viewport shading to solid, which you can toggle with this button at the top. To make the mesh edges more apparent, I'll click the drop down and check cavity. Next, click on the cube and we'll scale it to roughly the size of our hut. To make this easier, I'll provide exact measurements for the entire tutorial, but feel free to go by approximations. Open the side menu with shortcut N and set the dimensions to 2.5 in the X, 2.25 in the Y, and 3 in the Z. In front view, using numpad 1, bring the cube to the X-axis line by pressing G, then X. Next, I'll create support posts to line the corners of the structure. Add another cube with Shift A and set the dimensions to 0.3 in the X and Y, and 3 in the Z. In top view, using numpad 7, toggle X-ray mode with Alt-Z or by clicking this button. Move the cube to the bottom right until the origin point is centered on the corner. Then in front view, move it up to align with the larger shape. Back in top view, create a link duplicate with Alt-D and move it along the Y to the opposite corner. We're creating link duplicates so that any edits we make to one post will affect all of them. Now shift select both posts, press Alt-D again, and move them along the X to the other side. Now we'll create a door and frame for the front. Bring in a mesh cube for the door and set the dimensions to 0.75 in the X, 0.1 in the Y, and about 1.65 in the Z. In top view, move it in front of the structure's front wall, and in front view, raise it along the Z by roughly 3 grid squares. To create the frame, duplicate the door mesh and shift it slightly along the X. Set the X to 0.25 and Y to 0.2, and position it on the left side. Like the door mesh, make sure it sits on the front wall. Duplicate it for the other side and duplicate it again for the top. Rotate it along the Y with RY then 90 and set the Z to about 1.3. Position it centered and above the door. Next, let's create a doorknob by bringing in a mesh sphere and setting the dimensions to 0.2 all around. Place it in front of the door towards the middle on the right side. To finish, we'll create steps leading up to the door. Bring in another mesh cube and set the dimensions to 1.3 in the X, 0.5 in the Y, and 0.17 in the Z. Position it in front of the wall beneath the door and frame. Then duplicate it, moving it slightly forward and below the original. Now we'll add a window to the right side of the structure. Shift select the door and frame meshes, and in top view, duplicate and rotate them 90 degrees. Position them on the right wall, roughly in the center. Select the duplicate door mesh, now the window, and size it down in the Z to about 0.7. Then shift it up. Next, duplicate the top part of the frame for the bottom. Shift select the sides of the frame, tab into edit mode, toggle X-ray, and select the bottom points of the frame. Move them up accordingly to fit the window frame, and tab back into object mode when you're finished. Box select all the elements we've created so far, and send them to a new collection with shortcut M named Hut. Now, the last two elements we'll model are the roof and a small landmass for our hut to sit on. For the roof, the mesh we'll create won't be the actual roof seen in our render. That'll be done with grease pencil. We're just creating something for our strokes to adhere to. Let's start with the roof. Bring in a cube and set the dimensions to 3.25 in the X and Y and 2 in the Z. Move it up along the Z above the door frame, about 1.5 grid squares. In edit mode, select the top face of the cube and in top view, scale it down until you get a small rectangular shape to form a slanted roof. Then, using Ctrl R, add a loop cut across the cube and scale it out slightly, focusing a bit more on the X-axis. Slide the cut down by pressing G twice. Next, bevel the edges to smooth them out, adjusting the number of cuts with your middle mouse wheel. Make sure the posts don't poke through. They can slightly, but if needed, scale the cut to keep them obscured. To finish off the roof, let's add a log running across it. In object mode, bring in a mesh cylinder, set the X and Y to 0.75 and the Z to 2.3. Rotate it 90 degrees along the X-axis and position it on top of the roof. Then right-click and select Shade Auto Smooth. Select the roof and log meshes and send them to a new collection named Roof. Lastly, we'll create the landmass for our hut to sit on. Bring in a mesh circle and set the vertices down here to 64. Set the X and Y dimensions to 11. In edit mode with point select active, press E to extrude and S to scale inward a bit. Then press F to fill. Loop select the outer ring by holding Alt and selecting it, then bring it down slightly along the Z axis to create a small mound, and press F to fill the bottom. Add a loop cut across the mound and scale it with S to make it curve downwards. To smooth it out, tab into object mode and apply the scale with Ctrl A. This is important to make sure we bevel the mesh correctly. Then back in edit mode, shift select the two edges you want to smooth and bevel them with Ctrl B, adjusting the number of cuts as needed. When you're finished, tab back into object mode and right-click to select Shade Auto Smooth. Send it to a new collection named Environment. And that completes our modeling, and we can move on to shading. But before we do that, there are a couple of things I want to adjust first. We'll start with the render settings. Go to the Render Properties tab, and we'll be using the Eevee render engine. Scroll down to Color Management, and change the View Transform dropdown from AGX to Standard. This will help your colors appear more accurate for the stylized look we're aiming for. Below that, you can change the look to medium-high contrast. This is a personal preference, but it'll make your colors appear more vibrant. Feel free to experiment with this later on. Next, I want to set up a camera. It's always helpful to do this early on, so bring in another viewport by click dragging on the top right corner, and hide these side menus with N to see better. Set the left viewport to the camera view with numpad 0, and adjust the camera object in the right viewport until the hut is centered within the frame. I want to animate the camera rotating around the hut slightly, so bring in an empty cube. Parent the camera to the empty by shift selecting the camera, then the empty and hitting Ctrl P. Keyframe the empty rotation with shortcut K at frame 1. Then at frame 125, rotate it along the Z to the right slightly in keyframe. Lastly, duplicate the keyframe at 1 and place it at 250. Play this back to check it. You can keep this extra window open if you'd like, but since we don't need it right now, I'm going to collapse it by right-clicking this divider and selecting Join Areas. Finally, set the viewport shading to Material Preview, and in the drop-down, toggle Scene Lights and Scene World. Moving on to shading, let's first adjust the background color. Change the timeline down here to the shader editor by clicking this button down here and selecting it from the list. Select World from this drop-down, and in the node, select a lighter color. I'm going with a pale orange-yellow. Now, the shader we're going to create for our meshes can be affected by lights, so we'll want to separate the background color and its effect on the meshes. Bring in a mix shader with Shift A and place it in between the background node and world output. Duplicate the background node and connect it to the second slot of the mix shader. Bring in a light path node and connect isCameraArray to the factor input. Then bring in an RGB node. Copy the color of one of the background nodes with Ctrl C and paste it in the RGB value with Ctrl V. Connect the RGB color to both background nodes accordingly, so we'll only need to change one value for color moving forward. The strength value in the top background node will affect the objects, while the bottom one will control the color. Set the strength in the top node to 0.7. For the meshes, we're going to create a simple toon shader, starting with the landmass. Select the landmass and change the dropdown to Object. Create a new material and rename it landmass. You'll see a principled BSDF and a material output. Keep these in place. Bring in a shader to RGB with Shift A and place it after the principled BSDF. The shader to RGB is specific to Eevee and will help us achieve a toon look. Next, bring in a color ramp and place it after that. If you change the dropdown from linear to constant, you'll see the toon-like shading effect, which becomes more obvious as you adjust the sliders. You'll also notice that light affects the shading coverage, so I'm going to lower the light power to 500 and adjust its position. You might see some blurry artifacts on the shader which are due to shadows. In previous tutorials, I would usually recommend unchecking shadows, but here we'll leave them on. I'm also going to duplicate this light source and place it in front of the structure. Clicking back on the landmass, we can just choose the colors we want in the color ramp. However, instead of choosing colors directly, we're going to specify values so we can multiply them by a color and easily share this setup across the other meshes. For the first slider, I'll increase the value to about 0.4. Then I'll add another slider and increase that to 0.5. I'll leave the last slider as is, and then I'll adjust the slider positions as needed. Next, I'll bring in a mix color node, place it after the color ramp, and set it to multiply. Increase the factor to 1 and set the color to a nice green. Now the colors feel a little flat and I want to add some richness. going back to the color ramp, select the dark value and increase the saturation a bit, and shift the hue to a cool color. Then I'll do the same for the lighter value, but to a warmer color. Check it in camera view to make sure everything looks good, and we'll link these over to the other elements. Shift select the main building mesh, then the landmass, and hit Ctrl L to link materials. Select the building and click this number here to create a new material from this, and rename it to building. Then I'll select a medium beige color and adjust the coverage as needed. Next, link the material to the door. Select it, create a new material, and rename it dark wood. I'll select a dark brown color and link this to the log on top of the roof. Link the material to one of the posts. Select it, create a new material, and rename it light wood. Select a lighter brown color, then link this to the door and window frames as well as the step meshes. Link the material to the doorknob. If it looks jagged, just click on it and right-click to select Shade Auto Smooth. Create a new material from it, rename it knob, and select a yellow color. And lastly, link the material to the window. Select it, create a new material, rename it window, and choose a light blue color. Now for the roof mesh, we're going to make this a transparent material. This isn't necessary, but it'll be helpful for our grease pencil work in the next part. So if you are using an earlier version of Blender, no worries, as this step is completely optional. Create a new material, rename it transparent, and lower the alpha in the principled BSDF to about 0.2. Pop out the side menu with N, and under options, change the render method from dithered to blended. I'll also shift this color slightly darker for visibility. Check to make sure everything looks good in the camera view, and we'll move on to working with grease pencil. Now, the main elements created with grease pencil are the grass roof, the details on and around the house, and the outlines. Before we start drawing, we need to adjust a few options. Go to the View Layer Properties tab, and under Data, make sure Z is checked. This ensures that grease pencil will respect the Z space of meshes, and this will be helpful when we render. So if you'd like to do a test render during this process, it'll appear accurate. Then under World Properties, go to Viewport Display and set the color to white. It might not seem like this did anything, but grease pencil objects can be affected by light, and specifically this value. To demonstrate, I'll bring in a grease pencil monkey. When I lower the viewport display color, you'll notice the monkey gets darker. So setting it to white will eliminate any issues with color or appearance. Now we'll start with the roof. Change the shader editor here to the dope sheet, and make sure the 3D cursor is set to the world origin by pressing Shift-C. With your playhead at frame 1, bring in a new grease pencil blank, rename it Roof with F2, and move it to the corresponding collection. Next, go to the Material Properties tab to create our outline material. There are 3 types of materials we can create, which are stroke, fills, or both. We'll be creating a stroke material. Using the default material created, under Stroke, select a dark brown color and rename it accordingly. Then go to Object Data Properties and rename the layer that's created to Roof 1. In Draw mode, set the radius to 50 and leave Use Pressure toggled if you're using a tablet. Then set the strength to 1 and uncheck Use Pressure. Up here, you'll find the stroke location and orientation controls, which is how we'll draw in 3D space. Set the stroke placement to surface, which will allow us to draw with grease pencil on meshes. Let's also adjust the offset to 0.015, which determines the distance between a mesh and drawn stroke. You may need to adjust this value, but I recommend starting with this. Now to color, we're going to use Color Attribute. This coloring mode uses information from the base material we created, which is the outline material, and it allows us to change colors more easily. To toggle it, click this button up here and you'll notice the green picker box lights up. By clicking on it, we can select any color and down here, specify whether it'll affect just the stroke, the fill, or both. Since the base material we created is only a stroke material, that's what will be affected. When you draw, you'll notice the color changes to green instead of brown. First, select a dark green color for the base of the roof. Hide the log on top of the roof, and now we can start drawing. I'm going to line the edges of the roof first, and I'll do this in solid mode. If you want smoother strokes, you can toggle a pulled string-like mode by holding down Shift. Then I'll switch over to Material Preview and fill in the rest. Know that color attribute colors are not reflected in solid mode, so if it looks brown, no worries, as it'll be reflected in Material Preview. If you find that your offset distance is inconsistent when zooming in and out, try drawing an orthographic view, which will give more precise results. And you don't need to fill up the entire roof. Also, don't worry if it's not perfect, we'll fix it afterward. Just make sure you're starting all the way at the top to the bottom of the mesh. For this tutorial, I'm only going to finish the front and side of the roof, which is seen by the camera. Once you're finished, tab into Edit Mode, select All with A, and right-click to choose Smooth. Increase the repeat factor to clean up the lines. Then go into Sculpt mode. With the Thickness tool, increase the size of the strokes. I want it thicker in the middle and towards the top, and thinner at the ends. Also, to reverse the thickness direction, you can select this minus up here or hold down Ctrl while using the tool. Feel free to add more lines as needed. When you're done with your playhead at frame 1, create a new layer and rename it Roof 2. Click the drop down here and toggle Auto Lock Inactive Layers. This will ensure we don't accidentally edit the base layer. In draw mode, pick a medium green color and repeat the process. Again, line the edges of the roof all the way at the top and then follow it down. We also don't need as many strokes as the initial roof layer. Once you're done, go into Edit mode to smooth it out. Then into Sculpt mode to adjust the strokes. I want these strokes to be slightly thinner than those on the base layer, especially at the ends. Lastly, create another layer and rename it Roof 3. In draw mode, pick a lighter color and repeat the process. Again, we don't need too many strokes here. After, smooth out the strokes in Edit mode, and then in Sculpt mode, adjust the thickness. When you're finished, hide the transparent roof mesh and unhide the log. Make sure the roof portion is properly obscured by the grease pencil strokes and the log fits nicely on top. If you're having issues with the log, just bring it down to fit and increase the size of the strokes in Sculpt mode towards the top. Here I toggled the roof back on and I'm just extending the strokes of the light layer and toggling Auto Merge to automatically connect the ends. Now let's make a few more adjustments. Set the opacities of the Roof 2 and Roof 3 layers to 0.5 so they blend better. Select the light in front of the hut and increase its power to 1000 so it affects the roof. This might change the coverage of meshes, so make adjustments as needed. Click back on the roof grease pencil object and unlock the 3 layers. In Edit mode with Point Select, select a bottom point of one of the dark straw strokes. With Proportional Editing toggled or shortcut O, pull these points down along the Z-axis to add some length variation. You can adjust this with your middle mouse wheel. As a final touch, go into Vertex Paint mode and select the lighter green color. Set the strength to a very low value around 0.05 and go over the top strokes of the layers. Then select a darker green color and repeat this process for the bottom of the strokes. When you're finished, go back into object mode and now our roof is complete. Next, we'll move on to outlines. To do this, we'll use the Grease Pencil Line Art modifier. Bring it in by pressing Shift A and selecting Scene Line Art. In the Materials tab, replace the default color with the brown stroke color we created earlier. Then go to the Modifiers tab where we'll adjust the options. Set the thickness to 20 and the material to brown. Now, this modifier goes by the camera view, so go into it to check the outlines. By default, the line art will appear in front of other strokes, so to fix this, go to the Object Properties tab and under Viewport Display, uncheck In Front. Here, I'll want to play back the camera view just to check if there are outline strokes poking through the roof, and if there are, simply scale the roof object or the strokes inside it until they are properly obscured. Now we'll add detail lines to the hut. At frame 1, bring in a new grease pencil blank, rename it Hut, and move it to the corresponding collection. In the Materials tab, replace the default material with the brown one we created earlier. In the Layers panel, uncheck Use Lights for the layer that's created. Then, in Draw mode, set the stroke placement to surface with an offset of 0.015 and a radius of 20. Change the mode back to Material Paint mode to activate the brown color. In Front View, add detail lines to the front of the hut. I'm drawing them on the posts, door frame, and steps. Be careful not to draw over relationship lines or lights, as they'll mimic a surface when drawing. To hide them, you can toggle off overlays temporarily. For the wall, I'm adding horizontal lines. Then in Right View, I'll do the same, starting with the posts, window frame, then the wall. When you're done, click back on the roof grease pencil object and we'll add details to the log. With your playhead at frame 1, create a new layer on top of the layer stack named Details and uncheck Use Lights for this layer. Then draw lines across the log. Lastly, we'll add some environment details. In Object mode, shift right-click in front of the structure on the landmass to place the 3D cursor. Then, with your playhead at frame 1, bring in a new grease pencil blank. Rename it Environment and send it to the corresponding collection. I want to add some plants in front of the structure, so rename the layer that's created to Plants. Go to the Material Properties tab and bring in the brown material. Create a new material from it and rename it Green. Keep the stroke color, but toggle Fill. Set the alpha to 1 and choose a green color. Then let's also add another material slot and bring in the brown material. In Draw mode, set the stroke placement to 3D cursor and the drawing plane to front. This will orient your strokes to front view along the X. I find it easier to draw your elements in front view and then rotate them along the Z axis as needed. Go into front view and toggle off Use Pressure for Radius. Change the active material to green with Shortcut U and draw leaves sticking out. Then switch the material to brown, toggle Use Pressure, and draw lines within the leaves. Once you're finished, smooth and edit the strokes as needed. Then position the element in your scene accordingly. I'm using R and G, then Shift Z to lock transformations along the Z axis. Feel free to draw more elements as needed. At some point, you might encounter an issue where your line art appears in front of strokes from other grease pencil elements, or strokes may not be displayed correctly. I discuss this a lot in my course and cover some workarounds, but for this scene, it's related to the origin points of the grease pencil objects, specifically the environment one. To fix this, I shift right-clicked on a spot on the landmass behind the structure to set the 3D cursor. Then I selected the environment object, right-clicked, and set the origin to the cursor. Now for the final touch, I want to give this hut an angled shape. To do this easily, make sure your cursor is at the world origin by pressing Shift-C, and bring in a lattice. Scale it up until it encompasses the entire hut. Then Shift-select all the elements in the hut and roof collections and Control-click the lattice last. Hit Control-P and select Lattice Deform. Next, select the lattice and in Edit mode, select the 4 points at the top. Scale them out to achieve the desired angled shape and make any other adjustments. And with that, our jungle hut is complete. Now, these are optional, but I invite you to add some personalization and try these out to elevate your render, Also, these additional extras will be included in the downloadable project file. Before you make any changes, make sure the lattice modifier is turned off in the viewport or not added yet, as it'll warp grease pencil strokes drawn with surface or stroke in a weird way. The first edits I made were to the posts. Since we created link duplicates, it was easy to just edit the mesh. I also did the same for the log on top of the roof and added more details with grease pencil to it. I added more details to the roof like these flowers. I just created a new layer and used color attribute to create these yellow elements. And I also created these ropes hanging down from the roof. There are slight additional details on the grass roof, and this was done by creating a new layer and setting it to the add blending mode. Moving to the environment, I created these mesh rocks with the bisect tool and just applied the toon shader we created and set it to gray. I also added more foliage with grease pencil and some details on the landmass. To get it to glow in the final render, I added some quick compositing nodes, specifically glare. I added two, one set to the new bloom node and fog glow. I am going to do a proper video on this soon. Then I added a noise modifier on all the elements to get them to subtly shake and animated some of the roof elements. I then added a time offset modifier set to ping pong to get it to repeat. Now, if you are having issues with shadows, specifically on the shader, you can increase the shadow steps in the render properties tab. To render this out, go to the output properties tab. Here you can specify a resolution. I'm going to stick with 16:9, but if you want it vertical, you can flip these values, or you could make it a square. For the resolution percentage, I'll sometimes increase this to 150 to get a higher resolution, depending on the use case, but for now, I'll leave it at 100. If you want to export a sequence of images, specify a folder under Output and set the file format to PNG. If you'd like to export a video, change the file format to FFmpeg video, and under Encoding, set it to MPEG-4. Then under Video, change the output quality to perceptually lossless. Once you're finished, go up to Render at the top and select Render Animation. And that's it for the tutorial. Thank you so much for watching. I really appreciate it. I was really trying to create something shorter, but there was just a lot I wanted to include here. Anyway, if you'd like to learn more about grease pencil and this workflow in general, you can check out my course Magic Storybook over at cgboost.com. There, you can get access to the original treehouse scene I showed at the intro, as well as other various projects that cover a 2D 3D workflow. We'll start with learning grease pencil and gradually integrate it into a comprehensive workflow. There's over 10 hours of content and a comment section under each video that's helpful when and if you're stuck. If you do end up doing this project, feel free to tag me on social media at KevAndRam. If you have any questions or comments, feel free to leave them below. Thanks again, and see you all in the next video.
The idea was simple. If there's a good open source alternative, I'll use it. And since I made the last video, a lot has changed. You can use the chapters to navigate, and the video is structured like this. But first, recap. What does open source mean? Open source means the software's code is public and can be inspected, modified and audited by anyone, which is preferable to closed systems because it replaces blind trust with transparency, accountability and user control. Good. Arch. Not an app, an operating system. I make the rules. This is probably the biggest change. I now use Arch on my ThinkPad. By the way, I currently use the KDE desktop, but I've installed Hyperland, which I'm trying to migrate to, but it's not easy and I honestly quite like floating VMs. Still, I like Arch so far.
ella es la suma. En ese caso se presentaría en cuenca y municipio. Tampoco porque ella es la suma. Por VIP. Entonces, ¿qué significa? Provisión por vivienda, 300. Ay, ¿cómo voy a encontrar estos datos? Máximo 300. Ok. No está mal ahí. A ver. Total de viviendas particulares afectadas. Está raro. Población total de viviendas habitadas. 1. Viviendas totales. Población total. Porcentaje. Ok. 300.
far, and it's been great learning to use and just rely more on the terminal, which is pretty essential for my home labbing project as well. So yeah. Arch, by the way. Malware browser. Until a few weeks ago, I used the Zen browser, which is built on Firefox. It's minimal and I really like how it organizes tabs. They're organized vertically like this instead of the classic horizontal layout, but I've now switched to Malware. It's pretty rustic in terms of aesthetics, but it's probably the best browser for privacy. At least if we look at the overview on privacytests.org. Pretty bare bones, but I like it. I'm currently testing out a handful of privacy-oriented browsers, so perhaps look out for that video. Excalibur. Excalibur is a browser-based whiteboard tool that I now use for basically all of my videos. I think it makes very good visuals and it's very easy to use. LibrePods. LibrePods is a neat little tool that makes AirPods more usable on Linux. It helps bring back some of the features that normally keep you tied to Apple's ecosystem. OBS. OBS is what I use for all of my screen recordings. It does exactly what I need it to do. It's reliable and it has basically become a permanent part of my workflow. Audacity is what I use to record my voiceovers. My use case is rather simple, but for that it's perfect. Lightweight, straightforward, and it just works. Zotero. Zotero is one of those apps that genuinely makes my life easier, and I couldn't imagine not using it. It keeps my academic material organized, has a great PDF workflow, and if you're a student or doing research, I think it's incredibly useful. OnlyOffice. I've replaced the Microsoft suite with OnlyOffice. It does everything I need it to do. The file format worked well with the Copilot suite, which is crucial as I work with people who use Word and PowerPoint. I have a whole video about OnlyOffice and they have sponsored the channel in the past. However, LibreOffice is also a great alternative. VLC is just one of those classics. I've used it for years and it remains one of the easiest and most dependable ways to play
tenemos este. Poblaciones fuera de cuencas tienen que ser entonces. Pues sí. Ay, uy. Pues vamos a ver. Meterlo en... Iter. Bem census. Aquí. Corregir, explorar. Iter, explorar, CL. Y vamos a poner localidades. Ah, no, pero eso ya estaría. No. Eso estaría en Interlock. Columns. Sale de Cuenca. That is NA. Entonces, Entonces, ¿por qué? Cuenca. Tampoco. Aunque sea más grande. Mm, sea. Ok. Entonces sí los quita. Pero debe haber parecido desnudo. A ver, paso por paso. How, aquí está. Only left geometrical. Retain only. Arreglemos el escritorio. Solo vendría ese, ¿no? Necessary rivets. ¿Por qué no quedan en cuencas? Y son 381. Eso sí. A ver, pues. Ahí está. No, está mal. A ver. ¿Cómo lo recorté? Todas las columnas. Ujú. No es el mismo número. No, sí, es el mismo número. separada. Ahorita puedo decir. Se tiene que hacer. Vamos, vamos. Tú puedes. Turururum. 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 Está bien. Turururum. En Veracruz. Ah, también. No, pueden servir. Sí puede servir esta comparación nomás. A ver. Aquí qué estoy haciendo. GeoDF. No lo estoy. Pero no sé si son las mismas. No, sí, 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 son las mismas. más si uno de esos. Filas en original. No, este es el número que se tiene que repetir. No. Muy bien. Lo que sea de. Sí, tengo que comprarlos. Van a ser las mismas. Vamos a hacer la comprobación aquí. Ya está. Me lleva. 106.000 habitantes. Max 121.000. Ándale. ¿Cuál es esa localidad? Mínima 1. Arriba del 75-16. No, tengo que tirar acá y acá. Con geometría de puntos. Múltiples veces un geodata frame de puntos. Nada. Aquí no. Quiero poder regresar. Sin Cuenca. posicionar eso aquí. Los espacios. Entonces. Aquí eso no lo repite. Ok. Todo dimensional. Sí, sí. GDF. Direct calls llave. Este. Mm. Ya. Para el rato.